Okay, now we are going to talk about the different types of enzyme inhibitors, and we're going to use Lineweaver Burke plots to help us determine which one is which. So let's look at this table here first. Now, the types of questions that they're going to ask us to effectively pick out which inhibitor is which based on given context. Okay, so the first thing that we need to know is about binding preferences, binding sites. So this is a really easy one. Competitive, let me just run an arrow actually, is the only one that binds at the active site. Okay, all the other ones bind at allosteric sites. Okay, so that is a big one to pick out competitive. If they ever talk about an inhibitor binding at the active site, you know for a fact that's competitive. Is something that you guys also might be asking is about reversibility. If any of these are innately reversible. Reversibility, if I can spell. I don't even know if that's a word, but anyways, you'll understand. So no, we can't tell anything about it. We can only know if they are reversible or not. If given context. So when I say if given context, I mean if they have it written in the passage, okay? So none of these, at least for the MCAT, are inherently reversible or irreversible. Okay, so let's look at some more patterns because there's a lot of information here and this can be really intimidating. One thing, a useful pattern in which makes this table so useful is because it's in order of binding preference. So if we start at competitive, and I'm going to label this mixed A and mixed B. If we start at competitive, it only will bind to the enzyme when it's alone, when it does not have a substrate. And uncompetitive at the bottom will only bind in the enzyme substrate complex. In other words, when the enzyme has its substrate. Okay, so as we go from competitive to uncompetitive, we can see that there's a gradual increase in preference for the enzyme substrate complex. So we start at, okay, I'm only going to bind to the enzyme alone. Okay, I'm only going to bind to the enzyme alone, but I'm okay with a little bit of the enzyme substrate complex. Then we go to, okay, I don't care about either one. I'll bind to either of them equally. And then it goes to, okay, I actually prefer the enzyme substrate complex more, but I'll still have some of the enzyme alone. And then finally, enzyme substrate complex. Okay, I only care about the enzyme substrate complex. Okay, and now there are differences in Km and Vmax, and we are going to use these figures on the left that are called Lineweaver Burke plots to help us map these out. Okay, so they might just tell us this information in the passage, whatever happens, and we have to know which enzyme inhibitor that they're talking about. We have to have all of this memorized. Okay, but let's look at these Lineweaver Burke plots, and I know we looked at in the past video these curves over here. These curves are called the Michaelis-Menten curves. The Lineweaver Burke plots are inverse. It's just an inverse of that curve. So let's label the axes. Let's label the axes here. So the y-axis is 1 over Vmax. The x-axis is 1 over Km, and you'll see Km. You'll see some other things on the x-axis, but it's effectively 1 over the substrate concentration. Okay, so let's look at competitive first. So we have an increase in Km and no change on the Vmax. So we're going to find the Vmax at the y-intercept. Okay, and this isn't perfect. Ooh, actually, first let me label these. So this is the inhibited version, and then blue is uninhibited enzyme. Okay, so blue is uninhibited. When we put in the inhibitor, there's, for competitive, no change on the Vmax. So the Vmax is the y-intercept. That is not changing, but there is an increase in the Km, which is a little weird because the Km, or the x-axis, I should say, gets closer to 0. It gets closer to 0, the value of 0 here. So wouldn't that mean the Km is decreasing? No, we need to remember that the x-axis is 1 over Km. So even though the inhibitor is bringing it closer to 0, okay, it's bringing it closer to 0. So in other words, 1 over Km is getting closer to 0. So we can say that value 1 over Km is decreasing. In order to have that decrease in 1 over Km, that means Km itself needs to increase. Okay, so as we get closer to 0, Km is getting bigger. So as that value gets smaller, as it gets closer to 0, the Km is getting bigger. So we need to remember that is inverse. I mean, both the axes are inverse. Okay, and I know I talked about Km earlier in the last video. This is also inverse. So it's like a double negative relationship that you guys need to be aware of. So it's annoying, but with practice, you will get it, no problem. This stuff we have to have down and be able to pick it out from passages easily. Okay, so that's competitive. Competitive only changes the Km. It's only increasing the Km. Okay, the other one here. Okay, so continuing to non-competitive, and you guys might have noticed that edit because I need to fix the non-competitive plot here. Non-competitive has, it's the one in the middle here, non-competitive has no change in the Km and a decrease in the Vmax, okay? So no change in the Km, decrease on the Vmax. Okay, so the Km, once again is the x-axis. So that x-intercept, the x-intercept represents the Km. So there's no change there. There's no change there. But the inhibited version moves up. So the 1 over Vmax is increased, but the Vmax itself is decreased. Okay, so that's the inverse relationship that we need to be aware of. Okay, so the non-competitive is decreasing the Vmax and not touching the Km. A way to remember this one, a little trick to remember non-competitive with an N, if we draw in an extra line here, this looks like an N. So if you guys are forgetting, shoot, is it competitive or non-competitive that the Km stays the same? Draw the N for non-competitive. Okay, actually I'll leave that on there, so you guys have that. Okay, and so that's one tricky part. The other tricky part is between, and mixed A is pretty straightforward. It's the only one that increases the Km and decreases the Vmax. But the difference between mixed B and uncompetitive, this one is very tricky because both of them decrease the Km and they also both decrease the Vmax. Now you notice here with uncompetitive it says it decreases by the same factor as the Km. So there's a slight difference here between mixed B and competitive. So we can see for both of them, for both the inhibited versions, the y-intercept and the x-intercept on both versions gets bigger. Okay, so in other words, the Vmax and the Km are decreasing on both of them. But the difference is uncompetitive. Let's look at uncompetitive first. Uncompetitive, the slope is the same. Okay, so the inhibited and the non-inhibited will never touch. They'll never touch. They're parallel. So that's what they mean by it changes by the same amount as the Km. It changes by the same ratio. So the Vmax is going to change by the same ratio that the Km changes. So uncompetitive never touches, but for mixed, it does not change by the same ratio. So they'll eventually intersect at some point. Okay, so that's kind of the tricky part between mixed B and uncompetitive. And like I mentioned before, mixed A is its own kind of unique one. Okay, so just to reiterate this, I know this was a lot with Lineweaver Burke plots, but we need to memorize like every single characteristic, and they'll present us with a lot of information. Competitive, another thing about competitive that might present to us, they might say, okay, the substrate looks like this. It looks like this triangle shape. They say, okay, this might be the substrate. And then they might not tell us anything else about an inhibitor. They say, okay, here's our inhibitor here. They might not tell us anything else, but what we do notice is that the competitive inhibitor is the same exact shape as, or very similar shape to the substrate. That tells us it's competitive because it wants to bind to the active site. We know enzymes are specific and will only bind specific molecules in the active site. Okay, so all of this information is used to pick out which inhibitor is which. I hope this helps. Like, subscribe, leave some comments down below.